Okay, well, on my computer it's 2 o'clock, so I suggest that we start. Okay, so welcome everybody. Thank you all for joining this webinar. My name is Clemens Valens, and I'm a technical manager at Elektor Labs, and I will be moderating this webinar. This webinar is about the influence of the COVID-19 virus on the electronics industry, and is a supplement to the Elektor Industry magazine, the July 2020 edition, which has as theme Electronics in Challenging Times. If you haven't done so, you can download it from our website, and we will give the link at the end of the webinar on the overview slide. Here we go. So here we have a summary of what we will be talking about. A lot has been said in the newspapers and on radio and TV about COVID-19 in the past months, and many people are getting a bit tired of it all. So why yet another discussion about it? Well, we thought it would be interesting to talk a bit about how the electronics industry is reacting to COVID. Of course, as every company in the world is touched by, has been affected by lockdown and its consequences. The electronics industry also is, of course. But at the same time, the electronics industry has a lot of technology that can be helpful to fight COVID and other viruses. You never know what pops up in the future. So what kind of technologies are available and or are being developed to do this? That will be the main subject of this webinar. So I have 4 guests with me. In random order, we start with Markus Strecker. Markus Strecker is the founder and CEO of Teiimo. Markus, thank you for being here with us today. Markus knows all about wearable electronics, and he will tell us more about their connected T-shirt, how that can help detecting COVID in an early stage. Then my second guest is Doug Brown, Senior Marketing Manager and Product Evangelist for Honeywell Operational Intelligence. Hi Doug, nice to meet you. For you it's very early, right? Well, he's in Atlanta, I think.
Yes, so 8 a.m., a little after 8 a.m.
Okay, well, that's a correct time to do a webinar. The third guest is Jonas Proeger. Jonas Proeger from Trinamic Motion Control. Hello, Jonas, how are you? I don't see you in the video overview, but you were there a few minutes ago.
I am there, yeah.
Okay. Besides running the marketing department at Trinamic, Jonas is also a maker and open source evangelist, and he will tell us more about an open source ventilator project. Okay, and last but not least, we have Stuart Cording, who is now a SC on the video screen. I will give the camera now to him. Stuart is an engineer and journalist living in Munich. And, oh yeah, sorry, I forgot to advance the slide. Stuart wrote the theme article in the last edition of Elektor Industry entitled Industry and Community Respond to Coronavirus. So Stuart, can you tell us a bit more about your article?
Yeah, so just take my mask off. So I've been protecting myself prior to our call today. My personal background is that I've been in the electronics industry and the semiconductor industry for around 2 decades, and I've seen a lot of crises come and go. And yeah, mostly there's sort of natural disasters that interrupt the flow of semiconductors. At least things like typhoons and earthquakes cause factories that do, say, packaging of the silicon into the packages, cause them to sort of shut down briefly, maybe cause a delay of a week or 2, and you can normally get around those issues as a semiconductor vendor relatively quickly when you're supplying the automotive industry, which is a just-in-time manufacturing process. But COVID has really been a very big big challenge for everybody. The article starts by just looking back at the view of the engineering community who is participating in this world of electronics and semiconductors. And at the beginning of the year, I felt that, and I think the general feeling was that everything was actually quite good. Everything was working as expected, and we were going to have a good year. Nothing particularly special, but no disasters in sight. And the year starts for us really with preparing for either Mobile World Congress, which happens in Barcelona in Spain, or the Embedded World exhibition, which is where Elektor plan to exhibit as well in Nuremberg in Germany. And both those events happen at the same time in the same week. I guess the big difference between those two events is the Mobile World Congress really is truly international. Embedded World is international as well, but not to the same extent. It's more engineering focused and more engineering participants. You see lots of engineers and application engineers on the stands. But both of them were. There was lots of discussion going on LinkedIn, on lots of different other social media channels, saying, are these events really going to take place or not? Because in the weeks before Embedded World, there was actually the first corona case in Germany, which had been imported by a employee from a German company coming over to visit from China. And it's not far from where I live. It's about 30 kilometers south of where I live. And all of a sudden these people were in quarantine and corona was really here. And obviously people are saying, well, does it then make sense to travel to Embedded World and participate in this event? So Mobile World Congress unfortunately didn't take place, and that was mostly because the big companies that were attending pulled out. There was just no way that they could take on that risk, and also bring people in from really all over the world. Embedded World managed to continue, but a lot of the big exhibitors pulled out, and the picture you see here is actually from one of the new halls, 4A, I think. And this would normally have a big distributor in there, would normally have 2 or 3, 4 maybe semiconductor vendors in there, and there were just enormous gaps all over the place, which were filled with lots of benches, lots of sort of free spaces, and the show was unfortunately not as well attended as normal as it would be normally. Where in 2019 they had over 1,100 exhibitors and 30,000 visitors. This year the event had 15% fewer exhibitors and less than half the number of visitors that you would have expected. So quite a big difference, unfortunately, but was also sort of to be expected, bearing in mind the news and the rapidity with which COVID seemed to be spreading. So that was probably the first big shock, I would say, for the industry veterans, is that, this is really important, this is a big change. But then I think the next thing was about the supply chain issues. As I said before, it's not unusual that in the Philippines you have a typhoon or a tornado, and then as a semiconductor vendor, you can't package your silicon into the packages, and therefore you sort of do hand carries maybe to key clients, key accounts, in order to make sure that their manufacturing lines don't go down. But basically, everything just seemed to come to a standstill. You could potentially find somebody who was manufacturing some part, for example, MLCC capacitors or chip resistors or printed circuit boards. But even if you found someone that could still keep their factory up and running, there was no supply chain in between. There were no planes in the sky. There was no one working for logistics companies to pick the stuff up and drop it off. So basically, everybody was affected in the supply chain. One of the interesting things is the issue with printed circuit boards. Now, back in the early 80s, China had about a 2% share of the printed circuit board market, where today it's around 55%, which means that as soon as this happened, basically there were no printed circuit boards anymore. So, I think across the industry, everybody was infected in every conceivable way. So, here we go to the next slide. So there were 2 interesting things as I was writing this article that it was worth looking at, and it's the response of industry. How did businesses respond to what happened, and also the response of community, such as makers. So in the business segment, obviously engineers are engineers. As soon as there's a problem, they want to come and solve the problem. We'll remember the football team, and I think it was in the Philippines, that got stuck in the caves, and Elon Musk turned up with his submarine to try and rescue them. Engineers want to help. Engineers want to make a difference, and there's nothing like a global crisis to put everyone's minds into overdrive and figure out how they can help. And one of the biggest issues was obviously breathing issues amongst patients and not having enough medical equipment in order to support those that required some sort of breathing apparatus to help them. One of the interesting projects, which I think really epitomizes the skill and the best that engineering can offer, was Project Pit Lane. It was a consortium of UK-based Formula One teams who came together. And basically what they did is that they took an existing design for a CPAP device, that's a continuous positive airway pressure device. This is the sort of thing that connects to a mask which fits to the face and increases the pressure of the air flowing into the lungs. It doesn't do the breathing for you like a full breathing device, but it just provides assistance. And there was a real shortage of these, and it was considered at the time to be something that was going to be critical to lots of people through their illness. So the Project Pit Lane, they took an existing design which was already medically approved, which was another sensible step because that made it easier to quickly turn it around. And they worked with the UCL University in London to create what they've called the UCL Ventura, and that's the photo that you see at the top of the screen here. Now, they managed to go from the moment where they said, let's do this, to actually manufacturing the first prototype, manufacturing the first devices, in just 100 hours. And that was an approved medical device as well. So once they got to that stage, they actually took their manufacturing facility in the UK and reprogrammed it and set it up so as that it no longer made parts for Formula One cars like pistons and cams and all the rest of it, but turned their hand to producing 1,000 of these devices on a daily basis. Another interesting side topic, which people may have already seen in the wider press, was DNA nudge. Now, the big challenge with COVID, and one of the ways forward, I think, to combat it, is to test lots and lots of people to find out who's had it, and try to ensure by tracing their contacts that other people don't pass it on either, and maybe take a quarantine in order to not spread it further. So that seems to be the most effective way of combating COVID-19. The challenge, of course, is the testing, and lots of testing processes require the testing swabs to be applied on site somewhere where people are, like a car park, and then from there those swabs need to be taken and actually tested to a testing facility. The DNA Nudge team is a company that's actually been focused on DNA testing in the consumer space, and their idea was to actually use people's DNA to help them make better food selection choices when they are out shopping, use their DNA to analyze their body makeup, as it were, and help them to make healthy food choices and also make healthy choices with regard to fitness and exercise. But this DNA Nudge is actually a full DNA testing laboratory in a box, and using a small little what they call a lab in cartridge technology, you can actually feed your test swab into the cartridge, and the cartridge is then fitted into the DNA tester and can be repurposed very quickly for testing for COVID-19. So that's also another aspect that you see here. You see this ability to quickly switch from what we're doing today to something else in order to resolve an issue and tackle a challenge. Now, the community was obviously very active, but one of the biggest issues that was seen in the wider community, when you look at various websites and various sort of organizations that grew quickly to respond to the COVID-19 crisis, such as the New York City Makes PPE group, is that there were lots and lots of first version maker masks and visors and even breathing equipment being developed, and then we're never getting beyond this first stage, as there's one person here doing something, another person there doing something. And at the same time, these people, because they were in lockdown, they couldn't just walk into their local hospital and have a chat with people and understand what their needs and demands were, to find out, for example, what's comfortable to wear, what type of elastic needs to be fitted to these things, what are the standards that we need to fulfill, and so on and so forth. So this required some coordination, and it required organizations to come who were going to be a bridge between the existing maker community, which was desperate to deliver things and make use of, for example, their 3D printers, and also the medical staff at the other end who were going to be receiving this equipment to make sure they got what they needed, they got it in the quantities they needed and the sizes they needed at the times that they needed. So New York City Makes PPE was one of these organizations, and one of the things they did was settle on a particular type of visor. For example, there's one design called the 3D Verstärken, and it turned out to be quite comfortable, and it was easy to use and easy to manufacture because of its very low profile design. You could print lots of them all on one printer bed very quickly. So one night you could create 10 or 12 of these in one go. And that organization has actually managed to deliver 57,000 pieces of PPE by June 2020. They were also making lots of other things like the masks. When you wear them for long periods of time, they can dig into your ears, for example. So there were ear savers, which are little plastic bands that were created, and so on, and similar things being manufactured as well, all listed on the website. And there's advice to both parties, both to the medical community who needs these things and the maker community as well, who are capable of delivering them. So that was a success. And something else that came up was this NIH 3D Print Exchange, which is a government organization in the US. They came up with this 3D design, which goes onto an open platform. And this design is actually created to meet FDA requirements, although it's not actually been FDA approved. And in order for it to be used in a medical environment, it actually requires companies to step up who fulfill what's known as good manufacturing practices, and also fulfill a standard known as ISO 13845, which is a standard which proves, that you manufacture to a certain quality level. These masks as well, they need to be printed on, in order to be approved for use in the medical environment, they have to be made on a multi-jet fusion or a selective laser sintering printer, which is the MJF or SLS printing technology mentioned there. So you can't just use a 3D plastic printer that most makers have at home. But all the same, it shows as well that people come together. Industry wants to help through this channel as well and provide some support. So I think overall, when we summarize the whole article, the key thing to take away at the moment is what we're experiencing now is going to be normality for quite a long time to come. I think mask wearing is going to continue. In Germany, at least, we're seeing quite a strict adherence to the mask rules, at least in Munich, where I live, and I hear similar things from other European countries. I was in Greece recently, and they were also having making sure people kept their distance, wore masks, and so on and so forth as well. So, and it definitely does seem to be having a positive impact. It's the when people get a little bit lackadaisical about the rules, that we see the numbers start to go up as they have done more recently. In terms of our industry, it looks at the moment as though two big exhibitions, one of them is the SPS exhibition, which normally takes place in Nuremberg, which was delayed, and the Electronica exhibition, which happens every second year in November, are going to go ahead. But obviously that depends on the government approving mass gatherings of that size. So if things get much worse, it could be that they say, I'm sorry, it's too risky with that number of people. And they get delayed or cancelled as well. But at the minute, it looks like those trade fairs should go ahead, which for me personally is very exciting, and I look forward to be able to go and have that personal interaction, which we've missed so much over the last few months. But again, needs to be done sensibly and carefully.
Yes, about Electronica, you mentioned it. They do indeed plan to go ahead with Electronica, but I heard that one of the main problems now seems to be that the companies are not willing to go, actually. So you can organize a show, but if nobody's, and you can have visitors, but if there are no exhibitors, then you have no show.
That is a big concern, and I've had sort of private discussions with people in the last few weeks who I work with on a regular basis, And I think that sort of falls into two camps. I think you've got some companies who are on the organisation board of the Electronica trade exhibition, and they're pushing because they want to see this normality return. They want this opportunity to interact and communicate with people in person and have that forum. On the other hand, I think smaller companies who stuck it out and went to Embedded World, they're concerned that the rules that are being put in place are just too detrimental to a good experience. For example, my understanding is, I haven't seen the rules, but my understanding for Electronica is that there are rules such as you can only have a limited number of people on the stand. I saw a press conference with SPS, and their rules were, if you're on the stand for more than 15 minutes, you can take your mask off, talk to somebody, but once you come in that role, you then have to provide your name, address, telephone number for contract tracing purposes. And I think all this administration and complexity distracts from the fluidity of normal human to human interaction at these sort of events, and that is probably putting people off and saying, this just seems far too complicated to implement and detracts too much, and we're concerned we won't be able to provide what we want to do, and our visitors won't have the experience they expect.
Yeah. I went to Embedded in February, and the companies who were there, they were actually quite surprised that there were quite a few visitors, of course, but less than before, and there were less companies. And actually, they liked the show, or many of them, because they got more time to talk to the visitors. There was,
yeah, exactly.
They were thinking about smaller shows.
Yeah, I think Jonas was there, I think, at Embedded World with the Trinamic stand, and the feedback I got as well from lots of people was this has been actually more relaxed. We've had more time to talk to the people who did come, and the discussions we've had have been more valuable because they've been able to go deeper. And there is that aspect to it. The question is obviously whether people consider that to be valuable enough or not, and to justify participating.
Yeah, Jonas, were you there at Embedded?
Yes. So I mean, the first thing is, if we have that in numbers, we had, I think the Embedded show had 1/3 of the visitors of a typical Embedded World, and we had 1/3 less visitors on our booth than we typically have. But by the leads that we counted and that we qualified, it was basically the same than as we had in the years before. It was not more. The years before it was growing, but in this year it was flat compared to the last year, but still pretty good. So a show with less visitors but a higher quality is works.
Yeah.
More time.
In this respect, Electronica is enormous. And Stuart, so you mentioned these masks. Here in France, I live in France, everybody started making masks. On the internet, I saw lots of ventilator projects, but it seems to have quieted down a bit on the ventilator side. Do you think it's still a hot topic?
I do think it's still a hot topic, but I think that it'll be makers and engineers who really are the super dedicated that will continue that work. And the reason they'll do that is because it's essential. One of the ventilator projects that I mentioned in my article was the open source ventilator, which is a team in Ireland. And this was a proper ventilator, one that actually pushes air into the lungs. These are complicated things to make and also to get medically certified as well, because if you do this wrong, you can really harm the patient, if not potentially kill them. So you really need to be very careful with these sort of devices, which is why the medical industry is so hard to break into. There's lots of rules and regulations about it. What's clear is that it's not just COVID-19. There are many other illnesses and viruses around which attack and infect the lungs. Even Hurricane Katrina, for example, there were lots of people who needed ventilation after the Hurricane Katrina disaster. And many of them had to be treated using what they call, I just need to check the word here, a BVM. It's a bag valve, which is hand pumped. And that's okay for a short period of time, maybe sort of 10, 15 minutes or so. But these people will be in, medical staff will be sort of required to do this for half an hour or more, because they didn't have proper mechanical ventilators. Mechanical ventilators are exceptionally expensive. Not everybody can afford to, not countries around the world and medical services around the world can't afford the investment to make sure they've got this huge stock that they potentially might need one day if something happens. So a low-cost open source alternative, I think, is essential, and good luck to everybody who's out there trying to do this. But it's very, very challenging to do, because you need to consider so many aspects in the development to ensure you can fulfill the safety standards required.
Well, it happens that one of our guests, Jonas, is working on a ventilator. I think, Jonas, is that right? You are doing an open source ventilator project with Trinamic?
Yes. Yeah. Basically, in March, when the case numbers went up in Italy and later in Spain, we have been approached by many of those teams who were doing these AmbuBag designs. These how did you call it? I didn't know the abbreviation. So this silicon bag that you typically use to help ventilate people in an emergency situation, that is not meant to be used for a longer period of time. And many of those teams that were sometimes it were companies, sometimes it were it's been maker teams, it has been universities. One of those universities in the US actually got a device, one of those devices certified by the FDA, and the idea is that you have a mechanical device to compress this bag, which, well, the idea behind this is these things can be manufactured in vast masses, as all components are simple and are available on stock. And the other idea is better a bad ventilation than no ventilation at all, which sounds somehow compelling at the first glance. But finally, this is, even if it got certified by the FDA, this is really a last resort solution. So you have next to no control over the actual pressure in the airway, and you have no control over the airflow at all. And that's the two dimensions that you have to control in an intensive care situation. And the patients with SARS-CoV-2 are typically at a ventilator for about 2 weeks or so. So if you do that with a simple device like that, you can really damage the lung, harm the patient. The other thing is that we learned, I mean, when we started thinking about that, because many companies, many teams approached us, the other thing that we learned is when we were talking with doctors is that typically you will not, you try to leave those patients out of a coma or a artificial coma as long as it's possible. So you need a second thing. You need to detect, or if the patient is not in coma, it can happen that he starts to breathe on his own, and then you need to detect that, and you need to support the own breathing of the patient. So that means this is something you cannot do with these AmbuBags. So that's why we were thinking about how what stops us from having the real thing, trademark, the real thing manufactured in high quantities. And don't misunderstand me, Trinamic will not manufacture ventilators other than other teams who promise to do that. We will do what we can do, that is motor control and the electronics. So the engineers at Trinamic started to develop a solution, or a reference solution that can be easily and cheaply replicated anywhere on the world. And there were two things that you mentioned the supply chain issue in the beginning. two things that that can interrupt this supply chain. One thing is the blowers. So the most modern ventilator designs or state-of-the-art ventilator designs are using turbine blowers, BLDC turbine blowers, and the blowers that are used in intensive care ventilators are typically hand manufactured at a low quantity because there is no demand of that. And the companies who do that, they cannot just crank up their production when the proverbial shit hits the fan. So there is a limit to that, how many of them you can manufacture in a short period of time. And so we did the similar thing to this UK team. We looked for blowers that are used for CPAP devices. That's that's not actual ventilators. They just keep up the airway, but they are manufactured as a kind of consumer product. They are the bedside table for home care for people who have sleep apnea problems. So they are manufactured in hundred thousands. And we try to get as many of them as we could and check if they fulfill the demand, the pressure and airflow demand of a intensive care respirator. The good thing is that the German publisher Boyd made the standard documents available for a while, public and for free. So we could dig into that, and we found a few of these turbines and started from there, and then we started the development of the electronics based on our reference designs, and in parallel we started the development of the firmware. Because we used our reference designs for the hardware, we could do both things in parallel, and in the end, after a good week or so, we had the first prototype that was running that did the basic the basic demands for basic ventilation modes. It was not able to detect the own inhalation attempts of patients, but it worked so far. And from there, after another week, we had the final hardware. Hardware development was about 3 days. Software development was a week. Getting the hardware takes another week. Refining everything was about 2 weeks. So as we did it in parallel, about 3 weeks after we decided to do that, we had a setup there that fulfilled everything that we learned from our discussion with doctors who actually treat SARS-CoV-2 patients. We did no attempt to get it certified because we don't want to build the full device. We built a full machine just to show it's possible. That's the one you see on the slide at the side. It's mainly 3D printed. And it operates like a ventilator, but from here we give this to the open source and offer it to teams from anywhere in the world who develop and manufacture their devices based on that. I actually tested this on my own. It takes it takes a moment to get used to stop breathing and let a machine do that. I'm not so used in being machine ventilated while I'm awake, but it works. It detects inhalation attempts and it supports like a normal device would do that.
Okay, I noticed that your ventilator is based on a Raspberry Pi. That reminded me, we have our next webinar, which is in August, on August 13. There we have as guest Eben Upton, who is a co-founder of Raspberry Pi. So people interested in that might want to join that webinar. Anyway, yeah, ventilators. There is a question also in the chat box about all the companies that offer to do open source ventilators, and then in the end, maybe we never heard from them again. How many of all these projects are still active? I've seen a list a few months ago of open source ventilators that was pretty long. but I didn't check how many of these projects really made it or are still active. Do you know anything about these projects? Other projects still going on?
Not really. I know a few projects that we supported. I don't think that they ever manufactured more. Many of them are from Europe, and I think we are luckily currently we're not in the worst situation in Europe currently. We had a project from the University of Minnesota. That was the project who finally managed to get it certified, their device certified, but I don't think that any of those went to mass production.
Okay. Let's continue to our next guest now. So you talk about ventilators, we talk about social distancing, etc. It depends on where you are in the world, but here in France, lockdown is over. We are no longer being locked down, but it's in some places it's maybe coming back, etc. But people are getting back to the office, and we have to stay healthy. The virus is still around, as they keep reminding us. So we have to develop techniques or ways to enforce these or to help people respect these rules. And I will move on to the next slide. For this, we have Doug, who is from Honeywell. They help employees return to work.
Yes. So thank you.
Tell us something about this.
Yeah. So Honeywell's, we're involved in responding to this health crisis in many ways. Honeywell, as maybe some of you know, are definitely one of the big mask PPE producers in the world. Safety equipment's always been a big part of our ecosystem. A lot of fire safety is all coming from Honeywell. We're also into all the sensors that a lot of these new designs are based on. Honeywell is definitely behind those sensors. But what I want to talk to you about today is a software solution that leverages a mobile computer solution that we deliver. So if you really look behind the scenes, if you're in a warehouse or you see a delivery driver or even in a retail store, there's a lot of barcodes. And barcodes are kind of how we track the movement of products and things like that. Even in airports, we're using barcodes for our ticketing. And Honeywell makes that technology that can read those barcodes. So mobile computers is one of the examples. And so we looked at a software solution that we had called Operational Intelligence. It was something we already had brought to the market to add extra information to the ownership of this technology, of these kind of mobile computers. So it's not a mobile device manager as much. It's taking advantage of new sensors that we're putting inside of our products in order to capture new data and get a new perspective of how to get the most performance out of these kind of devices. But when the health crisis hit and we sent all of our engineers home from the lab to start working from their homes, we also challenged them to look at what could we do in our software solution to support the new work environment. Because while many of us got to go home to do our jobs, a lot of folks in warehouses and manufacturing and other industries, even delivering packages, those folks are still working. And that's created some challenges. So one of the first things we thought about was, could we help the workforce know and track social distancing? Could we help remind them that, hey, maybe you don't realize, but you're working too close to another worker? So one of the first things we did was took advantage of the radio technology that's in our mobile computers, and we basically developed software that has the ability to recognize when two of our devices are within whatever limits you set. Generally, here in North America, it's 6 feet, 2 meters. And so we can use our radio technology to recognize that. And then now what do we do with that information? And so there were several things that we that we do. One is we pop up a message. In this case, you'll see in the diagram, it's a big red screen that pops up on both workers' mobile device to indicate to them that, hey, you're working too close to another worker. You're within that social distancing range. And the moment they move apart, the screens change to green, and then they can go back to their normal screens if they need to do their job. In addition to notifying the workers, we're logging that information up in the cloud so that if a worker were, say, to test positive, you could then use that information to at least get some idea of doing some sort of tracing and tracking of, okay, what people do we need to go have a conversation with, because we know there's been a few, documented close encounters with other employees in the building. So that's been one of our first solutions that we delivered. Another one was having the ability to know, what people have devices, because it's one thing to know which device, but to know which person is also valuable in this time. But we also invented some software to do what we call cleaning alerts. And basically the design was to allow companies to define certain cleaning tasks that they want to assign to their workforce. And they can say what time they want that cleaning task to occur, which people would do which task. And then the worker, once they perform the cleaning event, would actually then could acknowledge, yes, I completed this, or no, I did not. And again, we're logging that information. So take, for example, if you're in a retail store and you want to tell your workforce, certain workers, I need you to go out and clean the shopping carts as best you can, or even clean your own mobile device. A lot of warehouse environments, the mobile devices are shared between workers, or if they're running 3 shifts, when they finish their shift, they're going to put that device back, on the table, and another worker is going to come in. So it's important that they clean those devices. So these cleaning alerts can be used for anything. Clean your work area, clean the bathroom, clean the shopping carts. It really doesn't matter. But this has been really valuable to remind employees, because I think a lot of it is you get busy doing your job and you kind of forget, hey, we're in this different time now. We're disinfecting and cleaning is an important reminder to think about. Another piece of software we added to operational intelligence was a people counter. And this is we're not using electronics to, measure, bodies walking through doors. We're actually using just people with a mobile computer with this piece of software. And they would be stationed at each door. And as people walk in, they press in. And as people walk out, they press the out button. We're synchronizing all the data from all the different doors in the facility. And we know exactly how many people are in the building. We know how many people you've decided is a safe amount because of social distancing. And the system will then start to warn all of the door monitors, if you would, that you're now reaching that level where you need to slow down. And so then they can start, each of your doors can start to monitor how many people are coming and going, so that you don't create an overcrowded situation. So it's, like I said, it's, while we actually have the technology to track exactly electronically, we were looking for something that was cost effective, something that could be put into place overnight. And that says, let's just deploy this software to do that. And then the last thing we added to our solution, again, I mentioned this system is not intended to be a full mobile device manager, which many mobile device managers on the market today already have this ability to do remote control, to take control of somebody's mobile computer to help them with running their application or reconfiguring their device or some sort of error condition. But a lot of companies don't have that kind of software. And so we went ahead and added this remote control ability so that your IT workers that are supporting technology and equipment don't have to go have that face-to-face interaction. They can remote into a device very quickly, see what's going on, see what the worker's experiencing with the screens or the applications, and make adjustments. They can even reconfigure the device, they can reboot the device, they can wipe the device clean and start from a factory reset. So a lot of those kind of control systems. We even have another system called Smart Talk, which is a voice over IP system, which allows customers that are using this technology to not have to have face-to-face meetings. They can actually now tell all of the employees, wherever you are in the building, stop where you are and we'll have a team meeting right now where everybody uses their barcode mobile device, and we can have a conversation and we can have a meeting. So all of this is just taking software to really remind and support all of the workers that are out there in the world, and more that are about to go back to work as we release some of the restrictions and give them some extra support in order to be mindful in this time that we're in right now.
Okay, so did I understand it correctly? Is this only one piece of software or one platform?
Operational intelligence is a single platform. It runs up in the cloud. But a lot of these components that you see here, some of them are web services, which means they run on any kind of mobile computer that has a radio, for example. Others of these, like the social distancing today, could work on other devices, but it's been tuned to run on our particular devices and our particular radios. But it would work on any device that has radio technology in it.
Okay, and so this is already, you have this working at Honeywell?
Oh yes, we have many customers that have already deployed this.
Okay, nice. Yeah, we are running a bit out of time, so we have to speed things up a little bit. So social distancing and hygiene, etc., are very important. But it's also important to detect people who have contracted the virus. You already mentioned it, and this is where Teiimo can come in. Let me move the slide forward, because they are working on a high-tech T-shirt that can help to detect people that have been contaminated by the COVID virus. Maybe you can connect your T-shirt to the Honeywell system as well, Markus?
Definitely, and I think maybe this is where I can open. What we do, we bring in the people, and we do like a second skin electronics device that helps detecting biometrical signals, and we have experience with all the different wireless transmission signals. We go highly integrated, as one of the aims that we are doing is always that the user should only have the functionality, but not really feel that he's carrying around some electronics. You see some examples as a sports shirt where we did a lot of testing. But listening to the conversation today, I really like our round here. Is, for example, if I think about the ventilators, and this is what's happening to us more often, that looking always centered at the people, we have a lot of technologies which could be used in other areas. For example, I was just realizing if Jonas, for example, his ventilators need something to detect breathing motions, we have sensors integrated, very thin, washable, and robust in a T-shirt, which is a thin textile where we can detect very easily a breathing motion without a lot of pressure on the body. This is all kind of technologies we have. And for DAG, what we also realized, we applied also for some a program in the EU, which was about the contact tracing, where we have a small electronics device, which is hybrid in the T-shirt. And we also have the technologies in there, the wireless technologies, to capture proximity with other persons. This means if you use one of these shirts, we can bring in information from a person which is completely hands-free. And if we make our job right, then he shouldn't even know or feel. He knows, of course, but he should not feel that he's wearing any electronics devices. And this is our aim. So the purpose of Teiimo overall is to make a long-lasting impact on people's life and inspire them and open new possibilities. And we always focus on the user benefits centered around the person. And what we do is creating, in fact, a new category of wearable products, like a second skin. And within the pandemic today, which is really an epochal impact on the world's economic, we realized, well, everybody was hit. And we at first also of course, had to check. We were running an investment round in spring and immediately stopped it with our partners. They said, this does not make sense. Let's focus on other topics. And then, of course, we talked to our customers, checked that what the status is, what they expect as an impact. And for example, some easy tasks, made sure that we have all the components from our supply chain in reach. So we had to pre-order some components because we didn't know if we can get the components for the next generation prototypes within the next 6 months. And by chance, we have a very good network there. And I will come back to the subject. So electronica for us was also immense. We had about 10 meetings scheduled with semiconductor suppliers and people we work with, which were mostly all canceled, and we moved immediately to digital. The big semiconductor companies, they couldn't risk to send employees abroad and get an infection into their workforce. So this was an immediate change. But so first also we had to check what's going on, what to expect, how our customers react, and we have good customers. So all our projects, in fact, after some first shock for everyone, continued. So we were good. And then we thought, oh, with our strategic project, which is our medical SHiiRT, if we would be here now, we can help immediately. And then we're a little sad that we are not fast enough. Then in the discussions, we realized that if there is a threat of a second wave, for example, this is completely in reach with what we can do with our electronics devices and especially our medical SHiiRTs. And in the medical SHiiRT today, we go up to, for example, 12-channel ECG we can do today in a T-shirt. This is all technology you can wear. And while talking there, we realized, oh, there is a chance and maybe a need in the future to use our devices. And then we just looked at alternative ways how to move forward in this area, and we put together a consortium. We found also a call for expression of interest under Horizon 2020 project and reached out to partners. And what we found out there, and our aim was, we have a SHiiRT which makes a patient monitoring, and with doctors we realized that we can detect most of the early symptoms. So if you go back to the slide before, so to the early symptoms, we realized that, for example, you have a WHO study which came out then in February with fever, dry cough, fatigue, shortness of breath, chills. And this is all things we could see with a T-shirt that the wearer is wearing on a daily basis. So we can detect the broad indicators for an early detection of the disease. And this was one of the main starting points for the discussion, because let's think about a nurse who has to take care of people and she's coughing. Yeah, okay. Coughing alone, if we run into autumn now, a single coughing may not be anything dangerous. But then if you if you have your sensors widely spread and you see on different aspects, levels rising or fatigue coming up compared to a daily normal, then this is a very powerful tool, especially to hinder the spread of the pandemic. So this was our main motivations. And then in addition to this, doctors discovered in New York that low blood oxygenation level can help with the detection, or gives an indicator how far the disease is progressed or is progressing. And this is also technologies we work on to integrate into textiles. With optical measurements, we can gather a lot of information about the body, and this is what we do anyway. So reaching out to people, and Elektor was one of them, we reached out as well. So Elektor is part of the consortium, and we put together people, for example, from universities working with artificial intelligence to be able to gather the data fast. So this is Politecnico di Milano, where we are working with there. We have a university, Technical University of Berlin, who is an expert in lung sound detection. Then we put together University Clinic of Heidelberg as for testing. So they were immediately also interested in joining the consortium. And this was also what we felt then. And this is also, let's say, for us, it was overwhelming that most of the end users we asked, they were immediately interested. So we have, in the consortium, we have 3 huge hospitals or expert clinics like Heidelberg. We have Brixana in Italy. We talk to Vienna, to Porto, and we have an elderly care experts in Romania who all would like to test the technology as soon as they have them. So we have a big pull from end users out of different areas and also hospitals where these kind of technologies can be used in the future. And then we put into the consortium some experts also who know more about the regulatory devices. And this is what we try to bring to life. So we dialed in now a proposal to the European Union for Horizon 2020 funding, which could start as early as in October. Let's hope we will be selected for the activity. And if this does not happen, we will be pushing forward our activities because we think that here we can really contribute to preventing the spread of a pandemic and helping people. And with the discussion we just had here, and this is also an appeal to people who are listening, if you are working on something and you need a feedback from the body with a t-shirt or just a textile part where we can do some sensing for you, for example, for ventilator, if you need a feedback from the body, then talk to us so we can see what we can provide. It's not so easy today. The technologies are not such that you can do them everywhere. There's some tricks, and we have a little prototyping facility here, but this can be scaled up in a short manner. So this is the story around our shirt. And this was really an experience that we felt. And after the first, let's say, like everyone, the first, wow, what's happening here? We saw, okay, this is something we can put energy in. And overall, what we see in our business, well, all we do now, the home monitoring or remote monitoring of people, of patients. We started with sports for the fitness, but in fact, today we are mainly working, and this is already a longer time, mainly on medical topics, of people with medical conditions. Has become even more important because if somebody is infected, a doctor would like to see his values and his measurements, but you don't have to make him go to the hospital if you have an efficient remote monitoring. And this is what drives us forward, and where I hope we can really bring also value to the society. What we will do now next month in September, we have a minimum viable product which we will put out on a Kickstarter campaign, as we had to stop our investment round. We can only move as fast as we also have money here. And the second thing which will happen on our side is also reopening our investment round for investors in the next 1 to 3 months. But what we look for is always alliances with other partners, like we have alliances with our customers in their core business, where we strive for a long-term relationship. And this is also what I can say, that we are open for this kind of cooperations to bring something to the society, to give back something and to help live a better life in this kind of a pandemic situation even.
Yeah, but many people probably don't know is that the Teiimo is just a startup. It's a small company. Actually, they won the Fast Forward Award in 2018 in Electronica that Elektor organized. So as a small company, you don't have the power and the resources of a Honeywell or Trinamic, who got a lot of money from Maxim, was it, who bought you? So you really need people or investors to come to you and help you further, right?
To follow our strategic agenda, an investment for growth is necessary here because we are small. On the other hand, we are not a typical startup because we are working with key customers in different subjects, and this is how we make our living. So we have on one side customer projects in fields that we don't enter, and we take care that there is no direct competition between our customers. So we solve problems or move things forward in areas which open new opportunities for our customers. So this is what we live from. But we are very small. Yeah, we are just 5 people. Yeah. And in the textile integration, we are within the leaders in the field today. And also sensor development. We have, for example, stretch sensors, which can stretch about 100%. And we have a resolution of 1 millimeter, a very precise detection of stretching. in absolute measures. So this is all the kinds of things we are working on. But yes, for us, it will be important that we can grow in the next months. And even what the pandemic was clearly pronouncing is the need for such solutions is immense. And also, if you need to wear a medical device, let's just think about a 24-hour ECG. If you can just wear a T-shirt and your data gets automatically transmitted, your life during this period where you wear an electronics device on the body is, of course, much more comfortable and easier.
Yeah, Doug, do you see something here for Honeywell? Maybe a connection?
I'm sure. I know another one of our safety divisions makes a lot of safety equipment for firemen. And I know sensing the stress levels and the health levels of firemen as they go into buildings. So yes, I think that is some very cool technology, could be used in a lot of different ways.
For firemen also, what we have a cooperation with German Telecom, and maybe we catch up on this after this. So there is a video out there where we added our T-shirt to the firemen, because as you pronounced, the stress on a fireman is important. What we are detecting is a medical ECG. We have heart rate variability. We have skin temperature, but this means we have a good insight on how he's feeling. And what we added on top of this is a motion sensor and an indoor location sensor for tracking the parts of a person indoors. So this means if the fireman runs into a building, we can tell, okay, now he went 5 meters up, he's in the 3rd floor, he went 50 meters into this direction in this pathway. And then if he has a medical problem or an emergency, with the new long-range wireless technologies, you can reach outside to control in the building, or even narrowband IoT. The new technologies in the 5G bands in the lower frequency ranges have a much better indoor penetration. So this means we can get information out, and you know approximately where to find the person, because this is based on inertial sensors. But in an emergency situation, if you tell the other firemen, hey, he's in a range of 5 meters in this area, they will find him, and they will find him much faster. So this is also one of our activities.
Yeah.
But this would be, I would be happy to talk to you about this.
Yes.
Great. We have a question from the audience. Let me see if I can get it on the screen. Is there something that your T-shirt could do here?
On the symptoms, I think what you need to do on the symptoms, you want to detect a virus which is airborne, in fact. So this is something I think would be great if we can go there. What we see today is the symptoms, but the analysis on the virus, I think, is more with sputum or with on breath. So there you need a different kind of electronics which does a complex analysis, and it may not be the ideal place to integrate it into the T-shirt you're wearing. So this is my answer, but if you have any ideas, please let us know. We'll be happy to check it out. So we are sensor experts as well. But in fact, we didn't look directly into the detection just of the virus. So we looked more at the symptoms, that we catch them as early as possible.
Okay.
The only suggestion I'd make is, again, back to the DNA nudge technology, which is sort of a DNA analysis tool. I think that's probably, in terms of electronic solutions, the only real way of actually detecting the virus. But obviously you have to physically go and, as Markus said, get a sample from the potential patient.
Yeah, we are working normally, and I said always escape today, implanting something into the body. We are working non-invasive. Here we are just staying on the outside of the body. Expect some examples if you would like, for example, inner body temperature. Then we can also work with technologies that you can temporarily digest, and then you get also very clear information on inner body. But this was not our aim to do a complex laboratory analysis of any body fluids today. But a lot of research is happening in this way. But I just think this research, which we could apply into the garments, is still a bit further out today. But we are having an eye on it on a monthly basis. With our network also, we are always checking for the new trends and potential possibilities.
Okay. I'm really looking forward to the T-shirt. I have now my silly Elektor T-shirt. It's a low quality. I would like one connected high-tech T-shirt would be much better than. Yeah, well, with this, I think I have to close the webinar. We have already passed the hour. Thank you all very much, Doug, Jonas, and Markus, and Stuart also, of course, for presenting your technology and your information. Also, you people watching, or the attendees, thank you very much for being there. Note that our next webinar, as I said before, is on the 13th of August. It's a lucky day when we will talk to Eben Upton and I forgot his name from Critical. It will be about embedded software or embedded development. Okay, thank you very much, and hopefully see you next on August the 13th. Goodbye.
Thank you.
Bye-bye.
Bye.